going to talk about double replacement reactions. In double replacement reactions, in this particular one, we have two ionic compounds, and both of these ionic compounds are soluble. So we have silver nitrate, and that AQ means that it's aqueous, or it's in solution, and so it's soluble, and it's reacting with potassium chloride, an aqueous solution of potassium chloride. And it appears that the cations switch places, and so we get silver chloride and then potassium nitrate. So it looks like these cations just switch places. So the potassium goes with the nitrate and the silver goes with the chloride. But really there's more going on here. What's happening is when the silver and the chloride ion meet, they form a precipitate. A precipitate is an insoluble solid that forms when two aqueous solutions are mixed. And so to show that it is a precipitate, we write the letter S for a solid. And so this is no longer in solution. It would form this really pretty white precipitate that would fall to the bottom of your test tube. And then you have the aqueous potassium nitrate still floating around in solution. Now, how do you know if something is going to be soluble or not? Well, you have to learn solubility rules. And so that's why you need to have solubility rules memorized. They look like it's going to be a terrible thing to memorize, but they're not so bad. So first of all nitrates are soluble. No matter what nitrate is with, if it's a nitrate, it is soluble. Also, group 1A metals, no matter what they are with, if it's sodium, potassium, lithium, rubidium, cesium, they are soluble. And so that's why we write aqueous. This was silver nitrate dissolved in water, and it dissolves. It's soluble. Aqueous, potassium, aqueous. All chlorides, bromides, and iodides are soluble, except when they're combined with silver, lead, or mercury. And so silver chloride is not soluble. And so you write an S there because it's insoluble, and that S stands for it's in a solid form in your reaction. And then here we have potassium nitrate. All nitrates are soluble, all group 1A metals. Potassium are soluble, so that is aqueous. So first of all, you've got to learn those solubility rules and find out what will form a precipitate. So you go ahead and you write your equation, and you just switch the cations around. So, you know, the potassium goes with the nitrate and the silver goes with the chloride. Write those formulas correct on your product side, and then you determine if they're soluble or not. And if they are soluble, write AQ, and if they're not, you write an S. But there are some things in this reaction that didn't change at all. They didn't react at all. And those are the things that were aqueous on the reactant side, and they're aqueous on the product side. And so we call those ions spectator ions. They didn't change at all. They didn't participate at all in the reaction. And so we should not include them in our equation. And so we have something that we're going to work on called net ionic equations. So first of all, see how this is aqueous? What that means is in solution you've got the cation, silver plus 1, the anion and nitrate. And then this is aqueous, so you've got the potassium ion and the chloride ion. And then it yields the solids. You keep solids together. They're not ions anymore. It's a solid at the bottom of the test tube. Silver chloride stays together. They're no longer ions. And then potassium nitrate, you separate that into ions because it's an aqueous solution. Now, once you get everything that's aqueous split apart into their ions, keeping all your solids together, if you had formed a gas, you would keep it together, or if you had formed a molecular compound, you would keep it together. But here we're keeping our solid together. Now you go back and you say, whoa, wait a minute. The nitrate was a nitrate as a reactant, and it's a nitrate as a product. And so it's a spectator ion. It doesn't participate like a spectator at a sporting event. And the other spectator ion up here is potassium. And so the net ionic equation is the things that did change in the reaction. Do not include spectator ions in your net ionic equation. So it's silver plus chloride yields silver chloride solid. So sometimes you can skip this step. If you see here the nitrate's aqueous, here the nitrate's aqueous, but then don't forget that in your net ionic equation you have got to show the charge on the ions. So this step is important, but some people can leave it out and make sure they get the right net ionic at the bottom. Up here as well, you can see that the potassium was an ion, it was aqueous, and it was an ion here, and so forth. All right, so we need to practice these, and you need to learn those solubility rules.